Hey everyone, welcome back. Ready to dive into some seriously cool tech today?
Definitely. Always up for exploring the cutting edge.
We're tackling chatbots in this deep dive, trying to figure out just how they've gotten so good at sounding like, well, us.
It's amazing how far they've come, right?
Absolutely. We've got a stack of articles and research papers here, some pretty dense stuff, but we're going to break it down so you can impress your friends with your chatbot knowledge.
Sounds like a plan. Let's demystify these digital chatterboxes.
Exactly. So first things first, what is a chatbot? When I say chatbot, what pops into your head?
I guess it's kind of like that helpful little pop-up window on a website, you know? The one that tries to answer your questions before you have to talk to a real person.
Right, or even those characters in video games that you can have a back and forth with. They're like early versions of this, right?
Totally.
Yeah.
But with a whole lot more AI power driving them these days, it's not just about simple responses anymore.
So it's more than just, if the user says this, then respond with that.
Way more. A real chatbot, it tries to actually understand what you mean, like a human would, and then it uses that understanding to hold up its end of the conversation.
So it's not just spitting out pre-programmed answers, it's actually processing the information and formulating a response. That's wild.
Exactly. And that's what makes them so powerful. And a bit mind-blowing when you really think about it. I mean, the first chatbot, believe it or not, was created way back in 1966.
No way. 1966. I had no idea they were around that long ago. What could they possibly do back then?
It was pretty basic, of course. But even then, the goal was to mimic human conversation using computers. And now, look where we are.
It's incredible. From basic text-based bots to voice assistants that we chat with every day, they're everywhere. And they're getting smarter all the time.
Right. And the way they learn, it's actually pretty fascinating.
So how do we teach a chatbot? It's not like we can just hand it a textbook, right?
Well, it's kind of like that, actually. Imagine you're teaching a dog a new trick. You'd use treats, right? Repetition, positive reinforcement. Well, chatbots have their version of treats, and it's called a corpus.
A corpus. Sounds kind of mysterious.
It's actually pretty straightforward. It's basically a massive, and I mean massive, collection of text and code. Books, articles, websites, even social media posts, anything that can give the chatbot a sense of how we use language.
So it's like feeding the chatbot a giant buffet of words and letting it figure out the patterns.
Exactly. It's all about pattern recognition. But it's not just about throwing data at the chatbot and hoping for the best. There's a structure and architecture to how they learn.
So it's like building a house. You need a blueprint, a plan. You don't just start piling up bricks. So what's the chatbot equivalent of that blueprint?
It's a series of steps, a process. It usually starts with, as I said, importing that huge corpus. Think of it like building a library for the chatbot to learn from.
Okay, so we've got our digital library all set up. What's the next step in our chatbot blueprint?
Well, just like you wouldn't want to learn from a book full of typos and errors, the next step is all about cleaning up the data. We call this pre-processing.
Makes sense. So no more misspelled mooms or grammatically questionable social media rants. Got to keep it clean.
Exactly. We want to give our chatbot the best possible data to learn from. Once the data is all cleaned up, it's time to break those sentences down into individual words, or even parts of words, called tokens. This step is called, you guessed it, tokenization.
Tokenization. So it's like taking apart a car engine to understand how all the individual parts work together.
Perfect analogy. By breaking down the text into smaller pieces, tokens, the chatbot can start to analyze and understand the relationships between them.
Okay, I'm following so far. We've got our giant library of text. We've cleaned it up. We've taken it apart and labeled all the pieces. What happens next?
So then, let's say our chatbot is trying to learn about different types of food, right? It encounters the word bake, then baked, and then maybe even baking. They're all different forms of the same word, right?
Right, so how do we teach the chatbot that those are all related?
That's where stemming and lemmatization come in. We're essentially teaching the chatbot to find the common denominator, the root of the word. So all those variations of bake would be linked back to the base form of the verb.
So it's like teaching the chatbot to see past the costumes words can wear and understand their core meaning. Very cool.
It's all about making connections. But here's the thing. Even though we've done all this work to break down language and find the relationships between words, computers still think in numbers.
Right, so how do we bridge that gap? How do we go from words to something a computer can actually process and understand? That seems like a pretty big leap.
It is a big leap, and that's where the magic really starts to happen.
Yeah.
We need to translate those words into a numerical form that our chatbot can understand. One of the ways we do this is using a method called bag of words.
Bag of words. Okay, I'm not gonna lie, that sounds a little strange. What's in this bag? Are we pulling out Scrabble tiles?
It's not as random as it sounds, I promise. Imagine you have a sentence like, "This is a really interesting podcast." The bag of words model basically creates a list of all the unique words in that sentence. This is a really interesting podcast.
Okay, I'm picturing it like each word is written on a little slip of paper and tossed into a bag.
Exactly. And then we represent each word in the bag with a vector, which is just a fancy way of saying a string of numbers.
So instead of saying this, we might say 100,000, and is becomes 0, 100,000, and so on. Each number representing whether a word is present or absent in a sentence. That's really clever.
It's a powerful way to turn words into something a computer can work with. But you're right, language is much more nuanced than just the presence or absence of words.
There's so much more to it, right? The context, the tone, the subtle ways we use words to convey meaning. Bag of words seems a bit limited to capture all of that.
You're absolutely right. And that's where we move beyond just counting words and start thinking about their meaning, their relationships with other words. Imagine a map. You wouldn't just see dots representing cities, right? You'd see their relative positions, their connections. That's what we do with vectorization.
Okay, now we're talking vectorization. I've heard that term thrown around a lot, but I'll admit I'm a little fuzzy on the specifics. How do we give words a sense of place, a location on this language map?
There's some pretty cool techniques for that. One is called TF-IDF, which helps us figure out which words are super relevant within a specific document, even if they're not that common overall.
So it's like finding those unique spices that give a dish its signature flavor, even if they're not staples like salt and pepper.
Exactly. Then there's word2vec, which is even cooler, in my opinion. It learns to map words based on their relationships with other words. So similar words like king and queen would end up closer together in this vector space.
So we're grouping our spices. Salt and pepper are probably close together on our spice rack, while cinnamon might be in a different cabinet altogether.
I like that analogy. And the closer words are in this vector space, the stronger their relationship, the more similar their meanings are.
Wow, this has been a wild ride. We started with those basic website chat boxes, and now we're talking about mapping the relationships between words like it's a digital galaxy. This is incredible stuff.
And we've only just scratched the surface.
Exactly. There's a whole universe of chatbot knowledge out there waiting to be explored. But for now, I think we've given our listeners plenty to chew on. We've gone from the what of chatbots to the how, and it's clear that these digital companions are only going to get more sophisticated. So, next time you find yourself chatting with a bot, take a moment to appreciate the incredible technology that's making that conversation possible. Thanks for joining us for this deep dive, everyone. Until next time.